Hello. Welcome to today's class. Uh, in this hopefully very short YouTube video, our goal will be to talk about chapter 3.7, okay? In 3.7, we are going to discuss arguments, and I think that this is an important part of everyday life. The reason why I say that is because let's put ourselves in a situation where we're trying to prove a point or disprove a point. We'll give ourselves, we'll say some given statements, and then we'll probably provide a conclusion and things like that. Think about it as when you're writing a paper. When you write in a paper, you begin by writing, of course, introducing whatever the problem is or whatever the issue is, but then you give supporting evidence based on whatever you're trying to do, and eventually you give a conclusion. So of course we're not trying to write a paper here, but we're trying to look at how is it that an argument is created in mathematics, and how do we translate here what we have, of course, words into symbolic symbols, or symbolic representation, and then so forth. All right, enough of the thing. Let's get busy. Okay. So an argument has two parts. It has premises and it has a conclusion. And so let's see. I'm trying to work this out. Oh, okay. Give me 1 second here. Let's pause for a minute. Let's pause for a minute. I'll be right back. So, oh, okay. Let's pause again. Let's pause again. And right now it seems to have lost my mouse. Where is my mouse? Okay. All right. I think I cleaned up all the glitches. So let's go. All right. So, as I was saying earlier, the argument is made up of premises and conclusions. Okay. So to keep our examples pretty simple, we will usually have two premises. So I'm going to label it as, oh, okay, there we go. Premise one, and this will be premise two. And this symbol right here that you see with those three little dots, it means that that is the conclusion. All right, so this particular argument, which reads, there must be a dam or there is flooding. This year, there is no flooding. So, in conclusion, this year, there is a dam. Okay, it's made up of two premises and one conclusion. Every argument that we'll look at will have premises and a very clear conclusion. Okay, so what do we do with arguments? We want to test their validity. Is the argument valid, or is the argument invalid? Okay, so an argument is either valid or invalid. And the way to show that is by using truth tables. Okay, so let's see what's next on the menu here. So this might look a little bit complicated, or maybe a little bit complex, too much wording. So what I'll recommend is, why don't you pause the video so that you can make your own notes, and then I'll go ahead and read through this. Okay, so but let's see what it says to do when it comes to determining the validity of an argument. One, we're going to use letters to represent each simple statement. Define variables. Express the premises and the conclusion in symbols. Okay, we've done things like that. But then this is part three is kind of interesting because it wants us to put all the premises. If I'm looking at here, all right, I want us to put all the premises together using the connective and. And let me try to highlight that using a different color. So what we're doing is, or what we're going to do is, we're going to put all the premises together using the connective and. Okay, so that's the first part. Okay, so we're going to put together the premises using the connective and. Okay, so that's how we're going to put them together. But if you look at the whole thing, okay, we are creating a conditional statement. Okay, if you look at the whole thing, we're going to create a conditional statement where the first part of it, is all the premises put together, and of course, the conclusion will be the conclusion, okay? So we can say that this is the antecedent, or I think I'm running out of room here. But again, this will be the first part of it, of the conditional statement, okay? And then those will be the premises put together using the word and then the second part of the conditional statement will be the conclusion, okay? We'll construct a truth table, okay? And then number 5, the thing is that in order for this thing to be valid, in order for the argument to be valid, the very last column has to be a tautology. The very last column has to be a tautology, okay? And so why don't we go ahead and put this to work, okay? Why don't we go ahead and put this to work, and let's see what kind of jam we get ourselves into. All right, so, all right, I think we are recording. Let me just triple check. We are recording. Yes, we are recording. All right, so here we go. We got an example, and it's the same one we were seeing earlier, okay? There must be a dam, or there is flooding. This year there is flooding. In conclusion, this year there is a dam, okay? So I'm going to start by labeling some variables. I'm going to say that the variable P will be that there is a dam. There is a dam. All right, let's see. Second variable, I see here that there is flooding, okay? There is flooding. Just remember that when we're defining our variables, we always want to look in the positive side of things. So if this would have said, for example, there will be no dam, then I still would have defined my variable as there is a dam. Okay, we always want to look in the positive side of things when we define variables. This premise right here reads, this year there is no flooding. Okay, well, that's basically the simple statement Q. And the conclusion is this year there is dam. So that means that's also the simple statement P. Okay, so there's no need for more variables here. However, what we're going to do is we're going to translate the argument from words to symbols. So let's see if we can go ahead and do that. There must be a dam or there is flooding. That is P or Q. This year, there is no flooding. That is the negation of Q. In conclusion, this year there is a dam. So that will be P. So what are we trying to do? We're going to create a truth table. We're going to create a truth table where we're going to connect this premise and this premise using the connective and. So we're going to put them together with the and. And then after we have that, we're going to write a conditional statement where this will be the first part and that will be the conclusion. Check this out. So this is what we're trying to do. Okay. Okay. We're going to put together P or Q with this. So this is the first premise. That's the second premise connected by the connective and. That will be the first part of our conditional, and where the second part of that will be the conclusion, okay? And this is what we need to create a truth table for, okay? And I kind of already done that and, give ourselves some preliminary work, okay? Again, notice that this first part of the, and what I'm missing here is something. Let me go ahead and fix this because I should have brackets here, right? Should have brackets here. Okay, so notice that what you're seeing here is there, of course, there is two variables, P and Q, but notice that there is a column for the first premise. There is also a column for the second premise. And what are we doing in this column? We are connecting the two premises with the connective and. Here, I have another column P because I don't want to get confused as I construct the conditional if this, then that. Okay. Alrighty then. Well, let's go ahead and get started with this. All right. The definition of P will be true, true, false, false. The definition for Q will be true, false, true, false. Something there didn't feel right, but okay. P or Q? Well, that would be true, 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 false. Because for the or, okay, it is only false when both of the components are false. So that is the first premise. This right here, this column is the second premise, which is not Q. Okay, we are negating that. We are negating this. We are negating that. And when we are negating false, that becomes true. What's going on in this column? In this column, we are connecting the premises using the connective and. All right, so that true and false will be false. True and true, now that is true. True and false will be false, and false and true will be false. These are the two premises connected using the word and. Here in this column, to make my life a lot easier, I am writing the conclusion. And for this example, it seems like the conclusion is fairly simple. It's just P, okay? But keep in mind that the conclusion might be a little bit more involved. So for another example, I don't expect it to be just P. It might be something else, okay? All right, so but we got lucky on this one. And P is true, true, false, false. What are we doing in this column? We are writing the conditional statement where the first part of the conditional is the premises put together with the connective and the second. So remember, it's a conditional. So we're going in this direction. If false, then true, that is true. If true, then true, that is true. If false, then false, that is true. If false, then false, well, that's true. What's the importance of this? Notice that the very last column of this truth table is nothing but truth values, true values. This is a tautology. So what's the big deal? Well, the big deal is that the argument is valid. So we have, based on the math behind this argument, we can say that the argument is valid. Why is that? Because the very last column of this truth table for this argument is a tautology. So therefore, the argument is valid. Okay. All right, let's look at another example because one example may not be enough. So let's look at another example. And here we have another argument. Okay. It reads like so. If it is cold, my motorcycle will not start. My motorcycle started. Therefore, it is not cold. What we need to do at first is define some variables. Okay, let's define the variables. Let's do that maybe here. P is the first simple statement, which is it is cold. Let's define Q. It will be the second part of this. So I'm taking, as I read the argument, I'm going one simple statement at a time. My motorcycle will not start. Okay, so we will say the motorcycle. I guess I could have said my motorcycle, right? So let's erase that and write my motorcycle. My motorcycle will start. Okay, so we always look on the positive side of things. When we look at this simple statement, my motorcycle started, then that's the same as simple statement Q. When we're working with arguments, we kind of disregard present or past, present, and future tense. For us, that kind of means the same thing, okay? The conclusion, it is not cold. It's just the negation of P. So I think we got everything here in symbols. All right, so let's go ahead and translate now from words to symbols. If it is cold, then my motorcycle will not start. That is a conditional statement. If, then. So we have if P, then not Q. My motorcycle started. That is Q. In conclusion, it is not cold. Excuse me. That is not P. So we need to construct a truth table for the following conditional statement. What do we need to do? We need to put these premises and put them together using the connective and. Okay, so first we need to do that. We need this premise and this second premise connected using the connective and. Again, we are creating a conditional statement where this conjunction, okay, will be first. And then we have the conclusion, which is not P. All right, so we need to create a truth table for this. Again, we're creating a truth table for this. So here I'm starting from scratch. So we need a column for P. We need a column for Q. Oh, this is where it is going to get fun. Okay. Again, we need columns for the premises. So in order to do this, I'm going to need a not Q. I'm going to need a not Q. And then I have if P, then not Q. Let's see if I can move a little bit here. And then we need a, okay, so then it seems like we already have the Q here. So you know what? I'll just go ahead and I'm going to leave it alone because I think I can jump between this and that column fairly simple. Okay. And so we are, okay, so now here, I'm going to put the premises together. Oh, wait, I put the wrong symbol there. I put the wrong symbol here. Okay, we're going to put the premises together using the connective and. So what I'm doing is, this is the first premise, this is the second premise, and here they're being connected using the connective and. And so let's see. In order for us, so now, okay, so now I'm going to need a column for not P. And then I'm going and the whole conditional. And Q, then and then not P. Alrighty then. I think we got everything that we need, and this is as straight as it could possibly be. Alrighty then. Hopefully we could be as organized as possible. Let's get started. True, true, false, false, true, false, true, false. If you need to pause the video, go ahead and pause the video. And so that way you can make construct the truth table, okay? Or maybe you would like to compare your final answer to my final answer. So I'll give you a minute, I'll give you a second if you want to pause the video. All right, let's continue. So not Q, false, true, false, true. We need to write the conditional if P, then not Q. Okay, so this if true, then false, that will be false. If true, then true, that will be true. If false, then false, that will be true. If false, then true, that will be true. That was the first premise. Luckily, we already had a column for the second premise. This is premise 1. This is premise 2. What's going on here? Premise 1 is being connected with premise 2 using the connective and. And so this and that will be false. This and that will be false. This will be true. True and true will be true. True and false will be false. Okay, so we connected the premises together. Now let's go ahead and have a column for the conclusion. The conclusion, once again, fairly simple, is just not P, false, false, true, true. And finally, we're ready for the last stage. Put those premises together with the conclusion using a conditional. So if this, then that. If this, then that. If this, then that. If false, then false, that will be true. If false, then false, that is also true. If true, then false, that will be true. If false, then true, that is also true. What's the big deal? Well, the big deal is that since this is a tautology, then the argument is valid. Okay, so if it is cold, my motorcycle will not start. My motorcycle started, therefore it is not cold. So that is a valid argument. Let's go ahead and do one more example. We have the following argument here. If we close the door, then there is less noise. There is less noise. We close the door. Conclusion is because we close the door. So let's go ahead and write some variables. The variable P will be we close the door. We close the door. Again, remember that past, present, and future tense is irrelevant here. Q is there is less noise. This, by the way, this is we. Okay, here we go. There is less noise. Let's write the argument in symbols. If we close the door, then there is less noise. That is, if P, then Q. The second premise is there is less noise. That is Q. In conclusion, we close the door. In conclusion, that's P. So what do we need to do? We need to create a truth table where we are putting the first premise together with the second premise using the connective and. That will be the first part of our conditional statement, where the conclusion, of course, is the conclusion. And the first part of that is where we put the premises together using the connective and. All right, let's try this again. Let's put a P, a Q. Let's write out our premises, which is if P, then Q. This is premise 1. Premise 2, you know what? I'm just gonna write it out here. I'm just gonna, no, I don't need to. I don't really need to. Let me just not do that because there's really no need for us to do that because we already have a column for Q. We already have a column for Q. So this is our premise 2. But what are we doing in the next column? In the next column, we're going to put together the first premise with the second premise using the connective and. Again, let me show you. What I'm doing is premise 1 connected with premise 2 using the connective and. That's what we're doing in that column. What are we doing in leading up to this? Leading up to this. Well, I'm going to put P here because that is the conclusion. Okay. And here we are writing the conditional. If this column, then this column. Okay. So here we have that conditional. If this, then that. If the premises put together, then the conclusion. Whoa, okay, that's as good as it's gonna get there. Let's extend these lines over here. I know over here we're kind of weird. It's got that menu coming up. Okay, so why don't you go ahead and pause the video, complete the truth table on your own, and then check with mine. I'll see you in a second. Alrighty then, you're back. True, true, false, false. True, false, true, false. If P, then Q. True, false, true, false. Remember that in the conditional, if the first part is true and the second part is false, the conditional will be false. What are we doing in this column? In this column, we're putting the premises together using the connective and. True, false, true, false. Remember, as long as both of the components are true, the conjunction will be true. That's what you're seeing here. P, let me write P again. So that will be true, true, false, false. What's happening in the very last column? We're going in this direction. If this, then that. If this, then that. If true, then true. That's true. If false, then true. That will be true. If true, then false. That will be false. If false, then false. That will be true. Okay, what's the big deal? This is not a tautology. Look at the highlighter. This is not a tautology because one of those outputs, I'm calling it outputs, one of these values, the whole thing is not true. Let me say it like that. So this is not a tautology. Therefore, then the argument is invalid. Let me select, oh yes, invalid. Okay. All right. So in this particular example, since the very last column was not a tautology, then the argument is invalid. Okay. Alrighty then. So we've done 3 examples. 2 of those have been valid arguments. One of those was an invalid argument. But I want to show you something here. Okay. There is a table on your book that can kind of summarize things for you. Okay. And so how to use this particular table? First, of course, we need to translate our argument from words to symbols. And if our symbolic representation matches any of these that you see here, and these are common or commonly used valid arguments and commonly used invalid arguments. So if any of our examples match exactly one of these, it saves us a little bit of work because then we could just give whatever the conclusion is, whether that happens to be a valid argument or whether it happens to be an invalid argument. For example, let's go back to our first example that we did. All right. And notice that in this example, let me just rewrite it. Okay. The let me see if I can use a different color here because I don't want it to get mixed up with all the other stuff. The symbolic representation of this argument was P or Q, not Q, conclusion P. Okay, this was the symbolic representation of this argument. Copy that down and meet me in a couple of slides. Okay, so meet me over there. Okay, so oops. That is this one right here. Okay, so how do we use this table? Once we have the argument translated into symbols, we can symbol for symbol check with this table. And it might be one of those commonly used valid, or it could be a commonly used invalid argument. So we could have saved ourselves a little bit of work by checking this table and saying, oh, since it is exactly this, it is valid. We could have said it is a valid argument because of the disjunctive reasoning, which has been proven, I guess let's say years ago. Okay. I want to show you another one. For example, let's look at our previous example. This was the symbolic representation. This is the symbolic representation. Then Q, conclusion P. That is here. So what we could have done for that example was, hey, let's look at that symbolic representation. Let's check the commonly valid and invalid arguments handout and see if it matches. If it does, then we can save ourselves completing the truth table and we can say, oh, it is an invalid argument because of the fallacy of the converse. So again, it's a very useful thing for being able to check whether it's using one of these commonly used valid and invalid arguments. However, we won't be able to use it all the time. Let's check why. This example here, let me see if I can delete this. This example here is if P, then not Q, if P, then not Q, Q, conclusion, not P. And if we write this down, now I guess let me pause because I need to write it down myself. It's not going to be one of the ones here. Okay, again, we already proved that it's valid, but it's not one of the commonly used valid arguments. Therefore, we had to no, I'm trying to think it's the contrapositive, but it's not. It's not the contrapositive. It looks almost like it, but it's not the contrapositive reasoning. In other words, not every argument will translate to one of these 8 examples. And so in that case, we're going to have to use the truth table technique to verify what happens at the very end. So some of them will work, some of them will not be on the handout. Okay. All right. This handout will be given to you on the exam. So this one will be so that you can use it. Let me know what questions you have because this will be the end of this video. I hope that this work helped you out, and thank you for being a good sport. So I'll see you later. And next time I see you will be for an exam on Thursday. But send me questions if you have questions. The review, the last 2 questions have a little bit more difficult because they have P, Q, and R. But you know what? Why don't we do this? Let me pause. And I want to show you one of those examples from the review. Okay, so hang tight. I'm coming back in 1 second. All right, so welcome back. So this is one of those examples from the review. And the difference between the review and what we did in our previous examples is that this has three different variables. So I need to show you how to do something like this, okay? And so it's already in symbolic form, so we don't have to try to um you know translate from words to symbol. Yeah, from words to symbols. So we just need to be able to handle something like this, okay? So we recognize that there is a variable P, a variable Q, and a variable R. Okay, so start here, here. Are you noticing that my lines are usually longer than usual? And I hope so, yes, because we have three variables, okay? Again, we need a column for the first premise. We need a column for the second premise, and this will be our conclusion. This will be our conclusion. So based on this, okay, in order to build the first premise, we need a not P. Oh, that's not the letter P. We need a not P. And we also need a not Q. Okay, and then we can build the first premise, which is the biconditional not P if and only if not Q. Okay, so here's our first premise. I guess I'll say is I got that checked out. I got it. I got it on my table. For the second premise, it is going to be if Q, then R. I don't think I need additional columns because I can figure I could see from here if Q. So here's our second premise. If Q, then R. But that's a very funky looking R. And then we need a conclusion. We need a okay. So I got this RP. You know what? I think I'm going to just say it. I think I could go ahead and get away with doing this. Okay, but I'll just be very careful as I go from here to here, from here to here. Okay. All right. I just didn't want to, I didn't think I needed that many more columns. Okay. So okay, so okay, no, I'm actually jumping the gun a little bit here. I'm jumping the gun a little bit. Let's rewind the tape. Let's rewind the tape. Because first we need to put together these premises. We need to put them together. So in this column, we have first premise put together with the second premise. What does that look like? Not P, if and only if, not Q, connected with if Q, then R. That is putting our premises together. Now we need the conclusion. I think I'm going to say if R, then P. Okay, that's the conclusion. And then the very last column will be the premises put together. So I'm running out of room here, so I'm going to do this. The premises put together. Oh, I need a parentheses. That I don't like the way it does. It is going to be the premises put together, and then with the conditional conclusion. Conclusion. Okay. So it's going to be the conditional between this column is going to be this column. Okay. And like that, you know, this is the conditional connective. All right, let's see how this works out. Let's go ahead and do this. Okay, let me go ahead and start this off. And of course, you can always press pause if you need to catch up. Okay, you can always press pause if you need to catch up. True, 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 false, 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 false. True, true, false, false, true, true, false, false. True, false, true, false, true, false, true, false. Notice that when building up a table, a truth table with 3 variables, it's a little longer, but because we're now doing 8 rows rather than just 4 rows, okay? All right, so not P, that will be false, 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 true, 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 true. Not Q, false, false, true, true, false, false, true, true. So it seems like when I'm doing something like this, I need to be a little bit more careful in how I'm approaching this particular example, because it's got a lot more rows, a lot more things to keep up with. Okay, so here we are connecting not P with not Q using the biconditional. So as long as they have the same truth value, the biconditional will be true. So because both of these are the same value, this will be true. Since they have opposite values here, that will be false. Okay, so I'm trying to keep up with. And here, true, 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 true. That means the biconditional will be true. All right, hopefully I'm keeping some sort of organized and I don't lose my rows here. We're going for the second premise. We have if Q, then R. So I'm doing this. Okay. Okay. For that second premise, I'm doing this. So let's see. True, false, false, true. I'm here. True, false, true, true. So here was if true, then false. And here we, oh, wait. I did a mistake here. Look, I made a mistake here. A mistake. Good thing I checked that. Good thing I checked that. Oh, where's the pen? Right here. Look, right here. Wait. That's not yet. This is good. If false, then true. That will be true. And this must be false. Yes, I'm just triple checking that I didn't make any mistakes there. All right then. What's happening in this column? In this column, we are connecting these two premises using the connective and. Okay, so it is only true when both of the components are true. So that will be true, false, 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 false. I need to keep my eyes wide open here, all right, so that I don't make a mistake. Okay. The conclusion. Okay, so we connected it, the premises. Now time to do the conclusion. The conclusion is RP. So, okay, maybe I could use a different color here because I don't want to get confused. So let's see if I could do this. Okay, bam, like that. You know what? I think I can probably get away with maybe doing a little bit of erasing here. Oops. Yes. Yes, that actually worked out. That actually worked out. And I need a different color though. So I'm going this way. I'm going this way. Look, I'm going this way. Going this way. Okay. So luckily, since I'm using a computer, that allows me to kind of delete relatively simple. Okay, so let's see. If true, then true, that's true. False, then true, that will be true. That will also be true. This would also be true. Oh, true, then false, that is false. This will be true. Oh, right here, once again, true. Then false is false, and this will be true. All right, finally, we're at the end. Now we're going to put together these two columns using a conditional, and this is the direction that we're going. This is the direction that we're going. And here we go. Let's see. True, 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 true. No way. False, true. Okay. And because this one value, and I did this for the other class as well, so I know that I worked out the same example, and the answer is that this argument is invalid. And this argument is invalid. Okay. But this is not one of those common valid or invalid arguments. So therefore, we must construct the truth table for this. Okay. And that's kind of the last two examples on the exam review. They could be a little bit on the, you know, I don't know what to say, time consuming side, but hopefully this gives you an idea of how to complete those type of examples that have three variables. All right, I think I'm going to call it quits because this is already much longer than I wanted it to be, but I hope that it worked out. And I'll see you guys hopefully on Thursday. Alrighty then, I'm calling it quits. Bye.